eliminated our fraction on that first one. Again, if you like dealing with a fraction or decimal, that's fine. But in my opinion, it makes it a lot easier. So we start out with delta H of the reaction. So delta H of the reaction, remember we label it as triangle or change. And then H is that enthalpy. And then Rxn is a reaction. Now the key to this, and the key to really this whole chapter, is products minus initial. So we start out with everything that the products have to offer with a bracket to represent we're dealing with those products. And then I'll need you guys for this. How many moles now of CO2 do we have? 4. Okay. We have 4 moles of CO2. And somebody tell me, if they can look up CO2 as a gas, somebody tell me what is that value we see for CO2? Perfect, negative 393.509. And that is kilojoules per mole. Great, fantastic. We close the parenthesis, and then just like our equation says, we have to add this other business. So we add how many now moles of water? 6. So we have 6 out in front. Moles of H2O times, what is that value for liquid water? Be careful because I list water a couple different times there. Perfect. 830. Yes. And that is kilojoules per mole. Now, we have all our products. Again, it's a long, stretched out problem. We then can shift gears to our reactants. So what we do here is we subtract, put another set of brackets to represent that we're dealing with our reactants. We subtract now how many moles of that ethanol? 2 moles. Now, this is not on your sheet. This is why I'm going to give you an expanded sheet here momentarily. And I think, Madison, you have that. If you look under carbon on that first page, yeah, flip this back and over here. Okay. What is C2H5OH?
Not on this one.
Oh, what?
Or was it the C2H2?
Oh, there it is.
Negative 1,273.02. The negative.
Yeah, there we go.
77.7.
Yep. So again, this is not on that chart that I gave you. I'll give you an expanded chart and we'll talk about how to use that. But looked it up and ethanol has this value. Now, just like we did for the last set, we have a plus sign and we have how many moles of O2? 7 moles of O2. Nice thing about O2 is what is its value? Yeah, so that makes it really nice for us. We have 0 kilojoules per mole. Now, again, we've made this big, long, stretched out problem. Couple key points. 1, we can't do brackets, so we'll start out with a parenthesis, so a double parenthesis. And then 2, think about your sign. So we'll start out double parenthesis, 4 times negative 393.509 plus 6 times negative 285.830. Parenthesis to close this out, and another parenthesis to close the bracket out. and then you have minus, start out with a parenthesis or this bracket and another parenthesis. So you have 2 times negative 277.7. And then the nice thing about this is plus parenthesis 7 times 0. And then we close out that parenthesis. And we'll give everybody a moment to try calculating. Anybody still trying to calculate? Okay, what do we get for our delta H value?
Negative 3,733.616.
And that would be in kilojoules. So again, same type of format as we had from the problem in the video. One thing, and this isn't required here, but what does the negative sign tell us about our enthalpy, our heat? Does heat go out or into? Out. So if it's going out, it's exiting. So this right here is an exothermic. And that just helps us, okay, what is the point of that? Well, hey, this stuff released heat. Now, ethanol, they use that sometimes in really fancy engines, like race cars and things of that nature. So, hey, you burned ethanol. Obviously, a car gets hot when it burns that fuel. So just some things to think about. Okay, questions on this? Key thing is products minus reactants, and then take your time with all the parentheses and negative signs and things of that nature. Does anybody still need this up here? Good. All right, we will drive on then with this next problem down below here. And it says here that we want to figure out acetone. Acetone's actually on none of those sheets, and so we have to go find that. Now, we're going to get a little bit different information, but the setup of the problem is essentially going to be the same. So what I'll start out by saying, or what I'll start out by doing, is saying ultimately we don't have a value for this guy right here. That's going to be our question mark. So we're going to start and we're going to find a little bit differently than we have in the past. Everything else is on that sheet. The other thing I want to talk about here is this is liberating 1,790 kilojoules of heat. Liberating is a fancy word for what? Getting rid of. Perfect. So it's getting rid of. That means, more importantly to us, that if it's liberating or getting rid of, it's going to have a negative value, 1,790 kilojoules. Okay. Now, this is our different starting point. Up until this point, we found delta H. Now we're given it. So how we start this problem is negative 1,790 kilojoules is equal still to our products first. So we look up and we say, how many moles of CO2? 3 moles. And we just had that from the last problems. What was that value there? We multiply that by negative 393.509 kilojoules per mole. We close out the parenthesis. We follow right along with what the equation says. So we say plus, open the parentheses, 3 moles of H2O, which 3 moles of H2O, what was that value we associated with liquid water? 8.3?
Yeah.
Perfect. Kilojoules per mole. That makes it nice there. These, again, are the products. We subtract from that, and this is where we're going to have a little bit of work. We subtract from that how many moles of acetone or the C3H6O? 1. This is going to be really important. So we have 1 mole times the value we don't know. So this is going to be times an X. And ultimately, we want to find that X. So I'll have to do a little bit of algebra to get to that point there. Now, we add to it, just like the equation says, how many moles of O2? 4 moles of O2 times, real easy for O2, 0. That makes life really easy. Now, our solving is going to be a little bit differently. What I would do, everything in this first bracket, I would put that into your calculator. So we'd start out with parenthesis, 3 times negative 393.509. Another parenthesis to close it out, plus 3 times negative 285.83. Put that double set of parentheses, and what do we get there?
Negative 2038.017.
1038.0.
17.
Okay, perfect. And that right there is in kilojoules. Now, this is still equal to that original amount of heat given off. So it's going to be negative 1,790 kilojoules of heat given off. This part right here we can do in our heads. 1 times X is what? It is just X. I'm going to go one step further, and I'm going to put 1 mole, and we'll see here why in a second, times X. And then this business here, 4 times 0 would end up being 0. So in math, you can just get rid of that guy because it's multiplied by 0. That means we don't have to worry about it. Now it comes down to some algebra. I like to get rid of my numbers, or I'll have my numbers on one side. So this is a negative 2,038. What do I need to do to get rid of it on this right-hand side? Add it. Perfect. So I'm going to add 2,038 kilojoules to both sides. And so when I have negative 1790 plus 238.017 kilojoules, we get what value?
248.017.
Perfect. 248.017. This would be kilojoules. Equal, and this is why I put the moles out in front, equal to negative 1 mole times X. Now, how do we get X completely by itself? Divide by negative 1, and that mole will play a role here to help with units. So if we divide this number by negative 1 moles, now what's our value become? Yep. So our X is negative 248.017 kilojoules per mole. Again, all it is, hey, we have a formula. We just got to rearrange or put in what we have and solve for what we don't. Any questions over how to do this? I think you're getting products minus reactants. If you can remember that, and all it is, hey, I just have to take the time to punch things into my calculator correctly. Okay, so I will